Here's what the actual walking and graph creation look like at regular speed. Let's take a look at what a distance-time graph means and how one can be created. The video on the bottom is a person using a motion detector to track their distance from this wall at any given time. The top screen is the printout from the motion detector. The x-axis, the independent variable, is the time axis, and the y-axis, the dependent variable, is the distance according to the time. So let's give this a shot and see what happens. So as the person on the bottom begins moving, they are moving away from the wall, meaning their distance from the wall is increasing. So if we go take a look at what that would mean in the top video, the line you already see is the distance time graph the person is trying to recreate. So as the person moved, they moved away from the wall, meaning their distance was increasing, so the little dots show up. On an incline, the line is increasing because the distance from the wall is increasing. Then if we go back down and look at the bottom screen, the person holds still for several seconds, meaning their distance from the wall is not changing. So if we go back and look at the top screen, that should be this horizontal line, where the distance stays constant. So as we roll the top video, you'll see the little dotted line showing up, meaning that the person's distance was staying the same because it's a horizontal line. If we go back down to the bottom video and make the person move, they move toward the wall. Their distance from the wall is decreasing. So in the video, that would be this slanted line that is going downhill, the decreasing line. So as we roll the video on the top, you'll see that the distance is decreasing, meaning the line is going downhill. And that's how you would create and interpret a distance time graph. Here's what the actual walking and graph creation look like in slow motion.
This picture from a calculator is an example of a distance versus time graph that my group created. The solid line is the original graph that we were trying to recreate. The dotted line is the person from my group's actual distance from the wall at any given time during this activity. There are a few things that this individual could have done to make their graph more accurate. The first being, they needed to start farther away from the wall. This individual started about 1 foot from the wall, when the original graph has the person starting at about 3.5 feet away from the wall. Another thing that this person could have done to make their graph more accurate is in the middle section of the graph, this individual was changing their distance from the wall ever so slightly. They would get a little farther away from the wall and then get a little bit closer. The original graph has the distance remaining the same the entire time, so the person just needed to stand still. And then in the original graph, the distance decreases, or the person gets closer to the wall. The individual in my group started by moving away from the wall again and then realized the graph was going the wrong direction, so started walking toward the wall. So instead of walking away from the wall first, they just needed to walk toward the wall. Those are a few things that this person could have done to make a more accurate graph.
This is an example of a velocity versus time graph. The x-axis is the independent variable, which is time, and the y-axis is the dependent variable, which is velocity. Velocity is a combination of speed and direction. You'll see that at the beginning of the graph, the velocity is at 0 and the time is at 0. Then the velocity climbs or has an increasing line. So on the first line segment, the person's velocity is increasing for the entire line. The next line segment is a horizontal line. On this line, the person has the same exact velocity for the entire duration of the line. Then the line turns and goes downhill, or it's a decreasing line. On this line, the person would be slowing down. Their velocity would be decreasing. They are still headed in the same direction, but they are moving at a slower pace. Right in here, where the line crosses the x-axis, the person's velocity is 0, meaning they have actually stopped. And you'll see that the line continues on through the x-axis. Below the x-axis, where the person has a negative velocity, that means that they have turned and are now going the other direction. And they are speeding up because the line is having a more and more negative value for velocity. This is an example of a velocity versus time graph.
This is an example of a velocity versus time graph that was created by my group. The original graph is the solid line. This was the velocity versus time graph that we were trying to recreate. The dotted line is a person from my group's velocity at any given time during this activity. As you can see, the motion detector had a little bit of trouble picking up the individual's velocity at the beginning because there are no dots. However, the person had a pretty good initial velocity right in here. It's very close to where the graph was, but then the graph levels out and is a horizontal line, meaning that the person should keep a constant velocity. But the individual in my group sped up a little bit because their dotted line goes uphill, and then they slowed down a little bit because it goes back downhill, and then they sped up and slowed down a little bit more. So instead of changing their speed, they should have just kept a constant speed. That would have given them a more accurate graph.